Okay, so today's notes say Introduction to Algebra Part 2. And let's review what we learned last time when we started algebra. Circle true or false for each statement. Algebra is a branch of mathematics that uses symbols in place of unknown values. True or false?
True.
Exactly, good.
What?
We have symbols like variables, x, y, or a smiley face, or a square, anything. How about this one? Algebra was invented in the year 1520 AD in France.
False.
False, that's right. Anybody remember where algebra was invented?
Arabic.
It's Arabic, right?
Persia.
Baghdad, right?
Baghdad.
Good. An example of algebra is 12 minus 7 equals 5.
False.
That is false because where's the unknown? There's no variable to solve for. That would be arithmetic. How about this? An example of algebra is 4 plus x equals 14. True, that's right. There is an unknown value there. It is okay to put the unknown variable on the right side of the equal sign like this. Is that okay?
Yeah.
So true, good. A true algebra problem always has x as the variable. False, that's right. You can have almost any number or symbol. To solve x plus 4 equals 10, you need to add 4 to each side. Good, that is false. That was tricky. You actually have addition here, so you're going to subtract 4 from each side. Remember, you do the opposite. If the problem y minus 8 equals 10, in the problem y minus 8 equals 10, the value of y is 18. Is that going to be true or not?
It's true.
It is true, that's right. You'd end up adding 8 to each side, and this would give you 10 plus 8, 18. If a fraction appears in an algebra problem, you don't have to solve it.
False.
Thank you. You must solve it, even with a fraction or a decimal. So far, algebra isn't as hard as I thought it would be. All right, I heard one true. I'm going with that. I'm going with it. Okay, so how many did you get correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 10. You only got one wrong? Good. So are you happy with your score? Give yourself a smiley face or a frown. So we are moving on. Today, we'll learn to solve basic algebra problems that involve multiplication and division. So let's start with multiplication first. It's going to be very similar to what we did last time, though. Think about the opposites. We're talking about opposites again. If the problem is multiplication, you will do the opposite and divide. Remember that multiplication gets paired up with division. Divide each side of the equation by whatever number is stuck to the variable. This right here, you'll always see algebra this way, 6x. You're not going to see it 6 times x. They won't write them that way. They're going to squish it together and put the 6 right next to the x. That means 6 times x. So this is a multiplication problem. To get rid of this here, these two things that are squished together, we're going to undo it with division. So next page. So our original problem was 6x equals 48. This is multiplication. We're going to undo it by dividing. I'm dividing by the 6 that is stuck to my x. Divide the left side of the equation by 6 and divide the right side of the equation by 6. And do you notice how you have 6 being divided by a 6 here? That's going to cancel out. 6 divided by 6 is really 1. 6 divided by 6 is 1. Cancel it out. And then 48 divided by 6 is 8. Your answer is x equals 8. So try this multiplication problem on your own. 5x equals 20. Can you tell that this is being multiplied here? The 5 and the x are squished together. That's multiplication. So do the opposite and divide. The question is, what number are you going to choose? I heard someone say it, 5. Right. And why did you pick 5? Because that's the number stuck to my x, right? Always choose that one. There you go. Same thing to each side. And the reason that we chose 5 is because look what happens here. 5 divided by 5, that's just 1. And I guess I could write 1x equals 20 divided by 5. But 1 times anything is just that number, so we can ignore that one. X equals 20 divided by 5, which is 4. Good. And that's how you solve an algebra problem with multiplication. All right, this one's not going to turn out quite so neatly, but give it a try. The first thing to notice is what operation is currently being done. 3x. What does this mean? That means multiplication. What's the opposite of multiplication? Division. Divide each side by some number. What number do you pick?
3.
Because that's the one that is stuck to my x. Gotta do the same thing on both sides. The reason we pick it is because 3 divided by 3 is 1. That lets me get rid of all those numbers on that side. And I'm left with just the variable. X equals 16 divided by 3. Now sometimes that's going to be your final answer, but what if I wanted you to give me a mixed fraction instead of an improper fraction? How would you do that?
5.
Good. You'd say, how many times does 3 go into 16 completely? And it does. It goes in 5 times. Because 5 times 3 is 15. Then you'd have 1 left over. Same denominator. Did anybody get 5 1/3? Excellent. Good. All right, so that wasn't so hard, but let's look at division now. And I bet you know what we're going to do to each side of the equation here. And it's the opposite. So, if the problem is division, you will do the opposite. Remember, division is paired up with multiplication. And you'll multiply. Multiply each side of the equation by the number under the variable. Remember that you want to get the variable all by itself on one side of the equation. So here's a problem. N over 5 equals 9. But how do you know that's a division problem? Because of the bar, right. In a fraction, the bar always means division. So this is a division problem because of this bar right here. So the fraction bar means division. It shows that the n is being divided by 5. So we want to get rid of the n, so we'll have to undo it with multiplication. So step 1, we're going to use a number to multiply both sides of the equation. And the number that we pick is the one closest to the n. It's right underneath it here. And again, why are we picking a 5? What happens when I do 5 times n over 5? 5 times n over 5. Look what happens to this side here. 5 over 5 becomes a 1. And 1 times n is just n. So there's really a reason why you pick the number that's closest to the n each time, because it allows you to do the canceling. So we've multiplied each side by 5. On this side, it's 9 times 5 is 45. I get n equals 45. This one will take a bit more practice. Next page. There is a division problem to try on your own. You how can you tell that it's division just by looking at it?
It has a bar.
That's right. Some number x is being divided by 3. That fraction bar means division. So the opposite of division is multiplication, and I sometimes like to show it in parentheses. I'm multiplying each side of my equation by a certain number. What number do I pick? 3 or 10?
3.
That's right. Pick the number closest to the x, which is underneath it here. So multiply each side by 3. Again, the reason we're doing that is because 3 times x is 3x over 3. That lets my 3's cancel out. I'm left with x equals 10 times 3, 30. Did anybody else get 30?
Do you have to put it in a parentheses or?
You do not. No, you do not. Remember, there's several different ways to show multiplication. You can use parentheses, you can use an X, you can use a dot. One of our assignments had, I think, a star, so lots of different ways. All right, try this last division problem, but there's another fraction. That looks kind of complicated. Where do you even start?
We'll find the 3.
Very nice, good. So you look at the variable side first. K is being divided by 2. The opposite of division is multiplication. So choose a number. In this case, you're going to have 3 numbers to pick from. 2, 1, or 3. That's right. You're going to choose 2. It's the number closest to the variable. And the reason we pick it is because it lets us cancel. 2 on the top with the 2 on the bottom, those can cancel. I'm left with K equals, and then this is back to multiplication of fractions. You multiply the numerators. 1 times 2 is 2, and the denominators. Do I multiply 3 times 2?
No, you need that one.
Yeah, this is a whole number, which is always over 1. You don't have to show it, but if you wanted to show it to see what your denominator is paired up with, it would be 3 times 1 is 3. So the answer is 2/3, and I would just leave it in a fraction form. All right, so practice solving these multiplication and division problems. All right, let's go over these now. Always the first thing that you do is you notice the operation that you have. 2 is next to the x like this. There's nothing between it. Can you tell what operation this is? This is multiplication. When the 2 is smushed right up to the x, that's being multiplied. What's the opposite of multiplication? Or the inverse? Divide. What number do I choose to use? 2 or 20? Right, and this is deliberate. We have a reason for choosing 2 because that lets us cancel them out. 2 on the top, 2 on the bottom becomes 1. X equals 20 divided by 2, 10. Good job. Same thing here. 4 times x. The opposite then is division. Do I choose the 4 or the 64? That's right. Again, that was very deliberate because now these cancel out. I have x equals, what is 64 divided by 4? 16? Good. Nice. Now one more multiplication problem. Divide by what number?
8.
Good. 8 on each side. Don't forget, what you do to one side, you must do to the other. 8's cancel. X equals 28 over 8. We could leave it, or we could say, how many times does 8 go into 28 completely?
3.
3, that's right. So 3 times completely, which would be 8 times 3 is 24. Then you would go 25, 26, 27, 28. There's 4 left over, right?
4 over.
And then you can probably tell visually that 4/8 is 1/2. So the same thing as 3.5. Did anybody get 3.5? Very nice. Good. Yes, if you reduce it, you could get 3.5. But this answer here will be fine as well. unless like a test specifies, right? All right, now these look different. Up here we had a number next to the variable, but down here we have the variable being divided by a number. So let's go back the other way. What's the opposite then of division? Multiplication. When you multiply the tops or the numerators. So what number am I using? 2 or 9?
2.
Again, we had a reason for that. We are going to do 2 on each side because 2 in a numerator cancels with 2 in a denominator. I'm left with n equals 9 times 2, 18. Same thing here. N is being divided by 6. So we're going to undo it with multiplication. Do I pick 6 or 11?
6.
That's right. Again, that was the reason for that. Because 6 can now get canceled here. I'm left with n equals 66. Nice job. Are there any questions then on these that we just did?